Hi everyone, welcome back to Kimband channel. We are discussing about Unit 1 solutions. In the previous video, we discussed about the types of solutions. In this video, let's discuss about the expression of concentration of solutions of solids in liquids. Okay, so in the previous video, we understood that there are different types of solutions, right? Gas in gas, liquid in gas, solid in gas, something like that. So uh, how to find the concentration of the solutes, the expression of concentration of solutions. So we start with the mass percentage. There are different types of percentages. The first one is weight by weight mass percentage. The formula for this one is mass percentage is equal to mass of the component in the solution divided by total mass of solution, okay, into 100. In a simplest way, you can write like this: mass percentage is equal to weight of the solute, component is nothing but a solute, divided by weight of the solution into 100. This is the short way you can remember the concept. Let's say, for example, you are having a 10% sugar solution. Okay, if I say the value is 10 weight by weight percentage, it means that it contains 10 gram of sugar in 10 gram of water. Okay, 10 by 10 weight by weight percentage means both solvent and the solute are taken in the weight format, not as a liquid ones. Okay, usually how we do for solutions, we take a solid and we dissolve in a liquid, right? But mass percentage, weight by weight mass percentage, for this purpose only gram weight is considered. Okay, so this is the basic of the mass percentage, mass weight by weight percentage, right? So let's move on to the next one, volume percentage, which is also known as V by V percentage. Okay, the formula for this one is also same to the previous one. Volume percentage of the component or the solute is equal to the volume of component or solute divided by total volume of solution into 100. You can write this in short as volume by volume percentage equal to volume of solute divided by volume of solution. Okay, here SOL means solution, S means solute or the component. Okay, multiplied by 100. Okay, so in your cough syrups and in some of the liquids, you might have noted these kind of things. Even for the liquids, alcohol solutions, there they mention 10% of ethanol, or 20% of ethanol, or 20% of uh, alcohol, which means that it has 10 ml of ethanol in 100 ml of water. Okay, so if they say 10 by 10, then it means 1%, right? So in the previous example also, if they say only 10 percentage, it means that they have taken 10 gram of sugar in 100 gram of the water, because percentage indicates the 100. Okay, so 10 gram of sugar in 100 gram of the water. So in this case, it is all about the gram weight, and in the case of a volume percentage, it is all about the volume. Okay, volume measurement, right? Let's move on to the next topic. Mass by volume percentage. Okay, this is the very common one we see in our day-to-day life. Okay, so this can be simply denoted as uh, sorry, W by V percentage is equal to, we can say, mass of the solute divided by volume of the solution multiplied by 100. Okay, example is 10% of sugar solution. In this case, 10 gram of sugar is dissolved in 100 ml. Okay, this is the volume, 100 ml of water. Okay, so here the terminologies are changing. So when somebody says simple weight percentage, most cases it will be like this. For example, they say 10% solution or 10 weight percentage solution. It means usually this type, mass by volume type. Okay, unless otherwise they say the volume of the uh, component or the solute, this is the type. Okay, so whenever they say simply as percentage or the weight percentage, it's none other than the type of this one. Okay, and always remember that here also it is weight by weight percentage. This one also simply can be mentioned. So look at the unit given for the solution. Okay, whether it is a liquid or the, I mean, ml or the gram. Okay, so let's move on to the fourth one. Fourth one is nothing but parts per million, which is also called as ppm. Okay, so for ppm, the book definition says that ppm is equal to number of parts of component divided by total number of parts of all components of solution multiplied by 10 power 6. The problem with this one is that you may not be able to calculate, or you may not be able to use this formula for calculation. So how to easily remember this concept? There is a simplest way to remember this concept. The actual meaning given here is 1 ppm is equal to 1 part in 10 power 6, right? 6 means you have to draw 6 zeros, which is nothing but 0.000001, which is again can be written as 10 power minus 6, 1 ppm. But when it comes to calculation, you will be given as a solute is having a 5 ppm of concentration or 10 ppm of concentration. They will give like that. So So for such purposes you should know this formula. 1 ppm is equal to 1 milligram dissolved in 1 liter, or 1 ppm is nothing but 1 ml dissolved in 1 liter. This is the core formula NEET aspirants or the board examiners have to remember for calculation purposes. Okay, they will say that you are given a value of 5.8 ppm of salinity. The problem is that you have to think in terms of millions. You don't need to think in terms of millions. Here salinity means it's nothing but the salt, so it means that 5.8 milligram of salt is dissolved in the 1 liter of the water in the given sample. Okay, like that. We can discuss another example. Let's say we have carbon monoxide 2 ppm in the air. In that case it is nothing but the 2 milligram of the gas is available in 1 cubic centimeter. 1 cubic centimeter is nothing but the 1 liter of the gas. Okay, so this is the formula for that. Okay, so for calculation purposes remember this formula so that you can know the conversions, and also you can apply in the examinations. Okay, let's move on to the next one. Mole fraction. Mole fraction, in fact it is the continuation of your 11th standard portion. Mole fraction. Mole fraction of component is equal to number of moles of the component divided by total number of moles of all the components. Okay, so let's say you want to find mole fraction of a component A. Let's say your solution has two components, A and B. Okay, we are about to find the mole fraction of component A. X is nothing but the mole fraction. For that purpose you have to find the mole of A, how much mole is dissolved. Again, mole of A plus mole of B. This is the way you can find it. This can be used for finding any number of components in a solution. Okay, mole fraction. And in fact there are some examples given in the book. Example 1.1, 1.2, they are all based on these calculations. I will brief the molarity and molality. Let's see what is meant by molarity. Molarity also a concept you have studied in the 11th standard. Still let's look at the formula. Molarity is equal to moles of solute divided by volume of solution liter. Okay, this may be good for the definition, but when you go for the calculation you need a very concrete formula, right? So note down this formula. Capital M molarity is equal to, this is the simplest formula. Okay, weight of the solute divided by molecular weight of the solute multiplied by 1000 divided by volume of the solution required. Okay, so this is the formula. Again I am telling you, this is nothing but molarity, this is weight of the solute, this is molecular weight of the solute, this is the volume required. This 1000 comes from the liter. Okay, so this is the shortest formula you can use for any calculations. Straight away you will get the answers, because for objective questions and all, you will not have the time to first calculate the mole, then calculate the volume of the solution, other things. Mole is nothing but the weight of the solute by molecule of the solute, right? So that is what I have directly implemented into the formula. This is the actual formula you can use for your calculation, molarity. Okay, so let's look at the normality. Sorry, we will look at the molarity. Molarity is same as the molarity. For molarity, we talked in terms of volume. In this case, we will talk in terms of weight. Moles of solute divided by mass of solvent in kg. So the simplest formula is m is equal to weight of the solute divided by molecular weight of the solute multiplied by 1000 divided by mass of the solvent in kilogram. That is the key. Okay, in the previous case molarity, the volume is in ml. In this case it is kilogram. Okay, so remember these formulas so that you can solve the problems very easily. All the best to you all. Let's meet in the next video.